The chain rule for derivatives, part 1. Let y equal f of g of x, then dy dx equals the following. F prime of or at g of x times g prime of x. Here's the way I say it with positioning. I say take the derivative of the outside part, leaving the inside part alone, times the derivative of the inside part. This proof is not too bad, so I will go through it with you. We're going to use the alternate form of the definition of the derivative, so the limit as x goes to a, if you recall this one, of, say, y of x minus y of a over x minus a. So we would write it out like the limit as x goes to a of f of g of x minus f of g of a over x minus a. And the way to handle this one is we're going to multiply by 1, but a very specific type of 1. In fact, we'll do this. We'll write f of g of x minus f of g of a over g of x minus g of a times g of x minus g of a. That is the 1 that we multiplied by. And then we have the original over x minus a. So this first part, as x goes to a, which means g of x goes to g of a, is the derivative of our function at g of a, or g of x. And this back part, as x goes to a, is the derivative of g at a, or g at x. Let's do some examples to help us understand it and just get some practice with the chain rule. So let f of x equal the square root of 1 plus x squared. So when I'm doing these problems, I usually say there's an outside part and an inside part. What do I mean by that? Notice that I could rewrite this as 1 plus x squared to the 1/2. So I have an outer function or an outer part, something to the 1/2 power. And then I have an inside part, or 1 plus x squared. So to find the derivative, I'm going to take the derivative of the outer part, or the outer function, which is the square root. And I leave the inside part alone. That's what this is saying right here. Take the derivative of the outside part, and I don't do anything to the inside part, times the derivative of the inside part. So times the derivative of 1 plus x squared, or times 2x. And if we were to clean that up, we would get 2 over 2, and then we have x over the square root of 1 plus x squared. Now, just a side note, I have done the derivative of square root of things very often. So if I have, say, f of x is the square root of some function, just call it g of x in general, then the derivative is 1 over 2 root that function as normal, but times the derivative of the inside part, up top like that, which is called the chain out, because we're doing the chain rule. Let's do some more examples. Consider g of x equals x cubed minus x to the 10th power. So we could multiply this out 10 times, maybe do a bunch of product rules or a lot of algebraic simplification, but instead we're going to do the chain rule, which says, let's take the derivative of the outer function, which is, our outer function is something to the 10th power. So 10, subtract 1 to get the new power, leaving the inside part alone, times the derivative of the inside part. That's how we do the chain rule. Let's do some more complicated problems. How about h of x equals the square root of 1 minus x times the cosine of 2x. Now, often we write it like this, but think I have implied parentheses there. Since I have a product, I have to do a product rule. So how do we handle product rule when I already know we're going to have a chain rule as well? It's this simple. The product rule says, let's take the derivative of this first piece. Okay, I have to take its derivative, and I think, what rules do I need? Well, that is 1 minus x to the 1/2. So when I take the derivative of this part, I have an outer function to the 1/2, if you would. Subtract 1 to get the new power, and we leave the inside part alone. But times the derivative of the inside part, which is -1. So I did the chain rule on the first part, and now I go back to the product rule, which says, let's leave that second part alone, and then plus. Now, we're going to leave that first part alone and take the derivative of the second part. So when I'm doing product rule or quotient rule, which has complicated things and derivatives kind of internally, I just wait till I get to that piece when I have to take the derivative, and I say, what rule do I need to use? Well, notice here I have an outer function cosine, if you would, cosine of something, and an inner function 2x, which says we're going to take the derivative of the outer function, negative sine, leaving the inside part alone, I left space on purpose, times the derivative of this inner function, which is 2, and I'll put it up front. Let's keep going. Chain rule takes practice, but students get used to it pretty quickly. How about the sine of x over 3, which I like to say is 1/3 x, minus the tangent of 4x, which would probably be written like that, but I'll put extra parentheses while we're learning it. Let's find a derivative. So how do I know that I have to do a chain rule? Well, it's because I have an outer function and an inner part that's not simply x. In this case, 1/3 x. So we'll take the derivative of the outside part, which is going to be cosine, leaving the inside part alone, times the derivative of the inside part. The derivative of 1/3 x is 1/3. I like it out front. And then minus, we have another outer function and another inner function. So again, we have a chain rule, because it's not simply tangent of x, but it's a tangent of 4x, more complicated, which says, take the derivative of the outside part, secant squared, leaving the inside part alone, times the derivative of the inside part, which is 4. All right, let's look at another complicated problem. What if we have y equals cosine cubed of 2 over x? All right, I have a bunch of stuff going on, so very often when I'm doing problems that look complicated, I will rewrite them in a way that I hope will help me. So I have cosine of something all cubed, and of what? Well, 2 over x, which is 2x to the negative 1. So how do we do a derivative like this? First of all, we have a big outer function, something cubed, which says we'll take the derivative of that big outer thing, 3 to the thing squared, leaving the inside part alone, times the derivative of the inside part. Now notice that this inside part is complicated as well. What we've done to this part is irrelevant. We need to find the derivative of cosine of 2x to the negative 1 power. So how do we do this? We do it by noticing that we have an outer function here and an inner function here, which says let's take the derivative of the outer function, negative sine, leaving the inside part alone, times the derivative of this inner part, which is negative 2x to the negative 2. You can clean this up if you like to, but this is how we do the derivative. Notice that we had a chain rule inside a chain rule. One more problem, because I like to do numeric problems. And consider f and g being continuous and differentiable for all x. I will state that without writing it. It's just going to allow me to do problems like this. And let's put some values down. Let's say x equals negative 1 and 2. And we'll fill in the table here with some other values that we may or may not need. And let's find the derivative of g of f of x. One thing I like to do, I like to switch the order of the letters at x equals negative 1. So how do we do something like this? Okay, it's the chain rule. I have an outer function g, inner function f of x, which says we need to find the derivative of the outer function, leaving the inside part alone. I'll put x for now, times the derivative of the inner function at x equals negative 1. And we'll continue on with this. We'll plug in some numbers. I have g prime of what? It's not g prime times, it's g prime of or g prime at f of negative 1. Not times. We're evaluating g prime at the point. This part is multiplied, so times f prime of negative 1. So let's simplify. F of negative 1 is 2. So I'm finding g prime at 2 times f prime at negative 1. And after all that, I can just plug in values for derivatives. So g prime at 2 is 4. F prime at negative 1 is 1/4. And we get 1. Let's do one more using this table. Let's find the derivative of the square root of f of 2x at x equals 1. You might recognize that I'm going to do a chain rule inside a chain rule because I have a big outer function, the square root, and inside I have another outer function and an inner function, like that. So how do I find the derivative of a square root? I'm going to do the shortcut I like, which is 1 over 2 times the square root of that thing That's basically taking the derivative of the outside part, leaving the inside part alone, times the derivative of the inside part. Where the inside part I'm referring to now is f of, or f at 2x. Okay, so let's take the derivative of f of 2x, which is the chain rule. What I've done up to this point is irrelevant. Let's just concentrate on the derivative of f of 2x, which is the derivative of the outside part, leaving the inside part alone, times the derivative of this inside part, times 2. I will cancel those 2's out. And we're going to do this at x equals 1. So we have f prime at 2 times 1 over the square root of f of 2 times 1. Now we can plug in. F prime of 2 is negative 1/2. F of 2 is 9, so the square root of 9. And simplifying, we get negative 1/2 over 3, and I'll put over 1 like that, so that when I flip and multiply my fractions, that is, when I flip the denominator multiply, I get the correct answer, being negative 1/6.